Hello, today we're going to talk about material transport systems. So mainly we'll just have a general overview of what is material handling in manufacturing shop floors, and also look at what kind of transportation equipment and devices are available in production. And lastly, we're going to do a little bit of analysis of how to calculate some of the key parameters or settings for material transport systems. Well, first, let's look at how where this material handling system and also identification system um, um, is located in this whole control diagram. In the manufacturing system, we have automation and also control technologies. We have manufacturing support systems and also quality control and a bunch of other functions. And one of those functions is material or handling, which is to deal with how to transport and how much materials to transport and how often to transport those materials from one station to another, and also from one building to another. So this also plays a very important role in production planning and control. A little bit different definition of material handling. It is a movement, protection, storage, and control materials and products throughout the process of manufacturing and distribution, consumption, and also disposal. So this is a general definition. Yearly, the estimated cost of of material transportation is about 20 to 75% of all the labor costs in production companies. Well, this number really depends on the degree of automation you implemented in your factory. If you have a lot of labor, then this ratio might be a little bit higher. But if you have a lot of automation, this percentage might be a little bit lower. But the cost can vary as well. Labor cost can go decrease, but also automation cost might go up. It's really a cost benefit analysis that you have to find out if it is worth it or not. And so there are several key factors when you have to consider when you are handling of the materials. It's all listed here. For example, it has to be safe, have to be efficient, low cost, and also in a timely manner. So there's no delays, and also accurately, so it can deliver the right material at the right quantity and at the right time, right, and also right location. And also make sure when you are transporting materials it's no damage. So it's like you're shipping something, you're mailing something to a friend. You want to make sure all the handling of your items or something of your mail to be safe and also arrive there on time. And so when we talk about logistics in production companies, we're really mentioning about actually two different categories of logistics. One is the external logistics, which is after the products come out of the facility, then it will be delivered to the customers or the dealers or the distributors. And there are multiple ways of transportation, for example by railway, truck, or by airplane or ships or a pipeline if it is some kind of liquid. And also there are some in another category is internal logistics, which is to handle materials within our shop floor, and also store our material at within the facility. Mainly in this course, I want to talk about internal logistics. And in terms of the equipment, so there are also several different categories. The one type of equipment is about, of course, it's transport itself. So which is, for example, AGVs or a conveyor belt, all those. Basically, they are to move material inside a factory, in a warehouse, or a facility. Another type of equipment is positioning equipment, which is to handle parts at one location. right? To make sure all the material are at the right location or right position. And another type of the equipment is the unit load formation. So, for example, you have a whole pallet, and that will be the unit load that you want to transfer materials. If it is not full, then you can calculate how much of the load, for example, half a load or 1/3 of the load. So from this you can easily group your material into a certain unit that easier for transportation, also for calculation. And for example, a box of materials, right? A pallet of materials, or a whole, a truckload of materials. And another type of equipment is the storage equipment, which is to store materials, right, like shelves, those kind of equipment. And also there are some identification and also control equipment, which is to keep track of material, make sure they are moved correctly and also stored correctly. And when you are designing your material handling system in a manufacturing kind of system, and some of the characters you have to consider about is what material it is. Material can be different shape, different size, different weight. So that also that changes the plan of the equipment you use, and also the size of the equipment that you have to use. Another thing is the flow rate, routing, and also scheduling. If you are designing material handling, if the material transportation is not very frequent, in this case you probably do not need a lot of automation in it. For example, you only need to transfer material from one station to another once a day, right? In this case, just use human labor, and they will be a lot cheaper than having an automated robot or AGV. If you have a mass production with a lot of volume of production, and then you have to think about the routing, right? So how to make sure the AGVs or the transportation routes are most efficient in this material handling. And also it depends on what type of production facility. It's like I mentioned before, it's customized with low volume or low variety, or it's a mass production with with low variety versus high variety. And it also changes the plan of that. For example, if it is with there's the production company does not have a lot of flexibility, or does not need to have a lot of flexibility, then you probably want to use a conveyor belt, and also build some of the tracks, trains, and they can deliver things. That is more efficient, and also that's cost effective as well. For that kind of a factory, you do not need to have a lot of flexibility. For example, use some robots to convey to transport those. Of course, most important part is the budget. If you have the budget to implement a material handling system or not, right? So, and also there are different plans for different degrees of automation in for the material handling. And other design considerations include the material is a solid, liquid, or gas. That might change the container, or the packaging, or the transport, the way of transportation, and also the size, the weight, the shape, condition. Also, if the material is fragile or not, brittle or not, right? And also some other safety risk you have to consider when we're designing your material handling system. And flow rate is also an important factor. As it is defined as the amount of material moved per unit time. So at a unit time, how much material actually moved. And the units can be pieces per hour, pallet loads per hour, or unit loads per hour, or tons per hour. And from this you can tell, okay, there might be a lot of material need to move from this station to another station. And from this you can have a general idea of how many transport equipment do you need, right? If it is very frequent, you might need more than one, right? If it is not really a high flow rate, then you probably do not need so many equipment, or maybe you just use some human labor to move it if it is flow rate is really low. And so routings, basically that's the routes, how the equipment goes through it. You can use some optimization methods to improve its efficiency, and to lower its distances, and also reduces routing variations. And scheduling, so basically the time of each delivery. When you are designing this kind of material handling, you have to think about trafficking. If there are a lot of AGVs or equipment going on, or transportation trucks going on, you have to think about what is the length of that, and how long does it take to transport materials from one station to another. Then that may affect the whole overall production cycle time. Some of the methods we have, if there are some of the bottlenecks, we talked about that before, so we can use some buffer stocks to mitigate the delays. Other design consideration might include the plant layout. So it depends on what kind of the process layout type. For example, the job shop. So job shop means you have the stations here and there, and it is not a typical production line, always one process after another. Job shop will be like you have one say machining process, right? There are multiple machines, and then next process will be maybe the welding. They have multiple stations for welding, and then multiple stations for painting. So that's more like a job shop. You do not have a clear product or process path. Well, in this case, material handling equipment, you can use some hand trucks, forklift trucks, or some AGVs. Well, if you have a clear production line, we know that from one process to another, it's one after another, then conveyor belts will be a very good choice. Also, you can use trucks or AGVs to deliver parts to each of the station, to support the materials. And if it is fixed position, fixed position will be like if you are making some of the big big products, or if you have to travel some of the big parts from one station to another, then you might use cranes or hoists to move them, and also some industrial trucks. So about unit load. So in general, unit load should be as large as practical for the material handling system. So because when we are designing a unit load, we have to think about how often we are moving materials from one station to another, and also what is size, the weight of the materials. And so we can take advantage of unit load, right? We do not want to have so many frequencies of travel, but with very, very low material amount. In this case, we are actually wasting a lot of either energy, electricity, or gasoline, and also the cost, right? Human labor cost. And so that's why we need to design the unit loads carefully. And so unit load containers can be a pallet. We have seen a lot in our lives, and also pallet box, which is actually to build a box on top of a pallet, or tote box. It depends on the size, materials, and the shape of materials. You can also use a box. So when people are talking about how much material they actually handled, they can say, okay, actually we did several pallets, right? One pallet, as you know, one pallet includes how much material it is. And in terms of the equipment categories, there are industrial trucks, AGVs, automatic guided vehicles, rail guided vehicles, conveyors, and cranes and hoists. We're going to look through it one by one. First, industrial trucks. So trucks can be powered or non-powered. So powered will be like we are using electricity or gasoline or some other source of power. Well, non-powered means we are using human labor, right? So the non-powered can be the two-wheel hand truck or four-wheel dolly, and or some hand-operated low lift pallet trucks like this. You can lift a pallet on this. If you add automation on top of this, for example, a motor, then you can call it a walkie truck, right? And of course, forklift truck. I assume you have seen this before. So someone's operating it, and you can lift it material from one place to another, and also packet it. Another one would be like the towing tractor. So towing tractor means it has a tow tractor. At the beginning, it's more like a train. Then have a trailer. Sometimes it can actually load several trailers together, right? More like a train. Another type of material transport, with more automation, that would be the automatic guided vehicles. So automatic guided vehicles, or AGVs, it's a material handling system that uses independently operated self-propelled vehicles guided along defined pathways. So that's the definition. So generally, it's a vehicle that can deliver materials by itself. For example, we have seen recently on our campus, we see a lot of food delivery, right? Food delivery cars or vehicles, and those actually have been started from a production shop floor, right? There are multiple different ways to calculate the routes, to sense the directions, and but at the beginning, they are just used for deliver material, transfer material from one place to another, and then later has been used in our lives. So AGVs can be the driverless train, like this, or pallet truck, or unit load carrier. So there is a video that it has a lot of good demonstrations of how AGV is actually used in production. We can watch this. So pay attention how a senses route, senses obstacles on the shop floor, and then how they change the directions from one to another.
It's just flawless, isn't it? I think so.
Sorry.
I literally couldn't.
So, my wife got me this weird new tool for Christmas. And at first, I
Sorry, so many advertisements. So you can tell this AGV actually loads the material from one station to another station. Sometimes they can move a little bit slowly, but it really depends on the speed you set. There are several considerations you have to think about when you are using an AGV. For example, the vehicle safety. You do not want AGV to move too fast because there might be human or workers walking on the shop floor, and you don't want to either hit people or hit something else. Also, when you have a lot of AGVs, sometimes they can cause some traffic problems, right? So, and in this case, you have to design it carefully to think about the schedule and material handling, and also the distance between the AGVs. So another safety protection is on top of AGV. Sometimes you can add have a light for some of the warnings. For example, if it has some kind of potential hazard or environment that might damage things, or it is getting too close to the human worker or some other obstacles, then the light probably can give some of the warnings. If you do not use light, you can also use sound or a combination of both sound and lights. So for controlling the AGVs, either you can use onboard control panel. For example, this one, it has control panels. There are different buttons you can hit, or you can use some remote call stations. So there is it can build some station that's a certain place, and then on that it have control panel and control the other AGVs, routes and transportation and controllers. And another one is you can use a central computer system to program and design all the routes. So that's also works. All right, so this is about AGVs, and we mentioned that the application of AGV is mainly that's either you have a good amount of material to transport, and also or you have large quantity or heavy materials to transport, and you need a lot of automation in it. And in terms of the methods for the pathways, as how do you design the guidance, right? There are different technologies. One is we can use the embedded wear that is embedded in on the ground. So the vehicle will actually sense the wear, and then because they create an electromagnetic field. From this, it can actually start to guide the vehicle. Another one is use strips, either color strips or some magnetic strips to guide the vehicles. Also, you can use the lasers, right? Laser or radar to sense obstacles and also places, and then to guide the vehicles. So really different technologies. Now because it's getting more smart, we can also actually build a map, right? The factory, and use some machine learning or artificial intelligence, other programs or algorithms to guide the vehicles. And for managing of the AGVs, one thing is we need to manage the traffic. So one way is we can use forward sensing. So what is forward sensing? So forward sensing means it can sense the material. It can sense obstacles or objects that are in front of it, and in terms of how far it is, what is the distance between it, and also the moving speed of the material of the object. So forward sensing has been used a lot in the cars. For example, especially autonomous vehicles. For example, self-parking, right? You have a car, they can self-park, especially parallel parking. So it can actually sense the forward, and also actually reverse, backward sensing. It also has that, so you can adjust it itself so that it can park the car correctly. Another traffic control for AGVs is that you can use a zone control, which means that each AGV is only can only transport or move within its zone. So in this case, a avoided you know vehicles either meet with each other, right, or not going into different zones. We discussed already about the vehicle safety. And another type of the vehicles is the rail guided vehicles. It's also very common, in production companies. One is fixed rail system. So for example, the overhead monorail. We can take a look at it. So this is combined with a robot arm with a monorail. See, all these equipment we actually already described in this course, and this is actually how the automation works in production companies. It's a combination of several automated equipments. And another one is on-floor parallel fixed rails. So you build the rail tracks on the shop floor. All right. Next is the conveyor systems. So conveyor system has been really commonly used in production. So there are two kinds of conveyor system. One is we commonly see in production. Another one is actually non-powered. There's no power. If you do not use power, there are a couple of ways to move things around. One is we can use human labor to move it, or we can use gravity. So basically, you design the the conveyor with a certain angles, and then the material will just fall along the conveyor from one place to another. You can see the orange stopper, so that's how it stops the part. Okay. All right. Another one is, of course, we have been seeing a lot. That is power conveyor. So there are different conveyor types. So this one is a roller type. Later, we're going to look at some other types. For example, the skid wheels, the belt. Sometimes you can see the tow line or some trolley. All right, so the conveyor types, roller, we have seen that. Then the skate wheel will be more like this type of skate wheel, and also the belt. For the belt, there's a driver roll and also the idler roll, so you can move the belt with in the looping. And another one is in-floor tow line. Take a look at this in-floor tow line.
Overhead conveying is a smart way to utilize wasted space above any work area. But in many situations, you need to move large objects that are either too heavy or simply too awkward to hang on an overhead system. This is where the strength and simplicity of a tow line system truly shines. In our constant drive to improve and take our products above and beyond, we also test and develop newer systems to meet the needs of our clients. This is our test facility for the PackTrack 100, which is a heavy-duty on-floor tow line conveyor. This new tow line has been configured and labeled a true workhorse with its ability to move greater loads than any standard tow line, and we are testing this system 24/7 continually. The PackTrack 100 features many benefits that we see as true advantages, particularly for the heavy load user. First is the extraordinarily shallow trench required to install a drive unit. A 2.5-inch recess cut into the floor is all that is required for this drive unit. There is no in-floor pit. There is no major floor work required to implement this tow line. It is also an easy cutaway to repair should the entire system need to be relocated to a new facility. It's easy to install, it's easy to use, and it's easy to move. The above-floor motor drive is also easy to service because of its accessibility. Second is the unique chain system. The heavy-duty PT100 chain has the strength to move mountains. Yet it's quiet, it's smooth running, and it also has a built-in chain slack adjustment. You'll notice at the drive unit exit, the chain has a unique telescopic feature that allows the chain to retract and adjust for the chain stretch or slack. There is no need for a take-up unit with this system since the chain has its own capacity to compensate. Thirdly is a curve load capacity. The PackTrack 100 utilizes heavy-duty, free-turning roller capstans to guide the chain and its load around any curve. This removes the chance of heavy wear on the inside of an enclosed track and also accommodates the movement of a heavy load through any turn with far less power required from the drive unit. As always, all carts are equipped with a bumper release mechanism that disconnects the cart from the chain drive should anything come in contact with a moving cart. Bottom line is, the PackTrack 100 is well on its way to proving its longevity, low maintenance, and its brute strength. If you're moving heavy loads through a warehousing,
Another type is the overhead trolley. There's a trap or the I-beam out there that you can use a chain to move it from one place to another. So it's more like our garage door system. Type of motions, and so there's a continuous type of motion, and also asynchronous. Continuous will be when the conveyor moves constantly. It won't stop. It just move at a constant velocity. Well, asynchronous will mean someone can move, can control its go and stop. For example, you finish your process, you can hit the go button, and the conveyor will move forward. And if you're working on this, then you can actually hit stop to stop the conveyor. So it's continuous and asynchronous type of motions. And another type of a classification of the conveyors will be depends on the direction how the conveyor goes. One is single direction conveyor, which is from one place to another place, from load to unload. It's just one direction. Once they move it is there. And another one is it's a loop. So you can put the load station at one end of the loop and also unload at the other end of the loop. So the conveyor will just go through the loops. And another one will be the recirculating. So recirculating will be like the conveyor belt we see in the baggage claim in airports, right? Once the materials is loaded on the conveyor belt and is waiting to be picked, so it just keeps circulating there until someone has someone picked up, right? So that's recirculating type of conveyor belt. Another material transport equipment we can see is cranes and hoists. So they are generally used in large equipment or heavy equipment for lifting and movement, either horizontal direction or vertical direction. So vertical direction we use hoists. Horizontal one will be cranes. But most commonly we use a combination of both cranes and hoists because we need to lift heavy materials up and also move it horizontally.
U-line gantry cranes can be used in conjunction with hoist trolleys and an electric chain hoist or hand chain hoist to hold and position heavy motors, generators, or machinery. Gantry cranes' lightweight aluminum construction allows for easy setup around job sites. Gantry cranes can quickly and easily adjust in height in 6-inch increments, from 7 feet 8 inches to 10 feet 2 inches, and feature a 1-ton capacity. U-Line's hoist trolley can be used with U-Line's gantry cranes or any I-beam between 2 to 8.5 inches wide. The trolley's universal eyelet is compatible with both hand chain hoists and electric hoist hooks. And hoist trolleys feature smooth rolling wheels that allow the user to easily position the trolley where needed. Electric chain hoists are used for applications that require frequent lifting. They lift 16 feet per minute and can be used for 30 minutes continuously. Simply press the up or down button to raise or lower the load. Hand chain hoists should be used for less frequent lifting. They are lightweight and can be moved around the job site. At capacity, the half-ton requires 29 feet of pull to lift 1 foot and the 1 ton requires 37 feet of pull to lift 1 foot. Whatever your material handling needs are, you can rely on Uline to have the solution.
All right, so last, we're gonna look at a little bit of analysis of material handling system or transportation system. Well, programming of the routes and also making schedule of the routes can be a really complicated problem, but we can do some general calculations about cycle time and also how many AGVs we need and how much time do we need for transportation. Those kind of analysis in production as manufacturing engineers or managers. So the calculation is fairly straightforward actually. If you want to calculate the deliver cycle time, so cycle time it really includes the time to load the material and time to unload the material as well as the transportation time, right? So transportation time will be considered into two different transports. One is we carry materials. Another one is we do not carry materials, which is to come back, right? To come back. So I think there's a little bit of this is not actually this arrow should be here. Okay, this arrow should be here. All right. So this is the distance to to travel empty until the start of the next delivery cycle, because the equipment have to come back to this loading station. And this is the distance for travel between load and unload stations. All right. Some other terms we'll see is available time. So available time means in an hour how many minutes the vehicle actually is available. So why we're talking about their automated part that should be 100% available? No, not really, because sometimes there can be a bit of traffic, right? So it might delay a little bit because they have to wait, and also it's the worker efficiency, for controlling it, and also a little bit wait at the loading and unloading area. So that's also some kind of efficiency we have to consider when you are talking about the availability of AGV or equipment. So there's availability factors, there's a traffic factor, and also worker efficiency out there. And in order to calculate the general available time per hour, this will be 60 is a converter to minutes. Converter to minutes. Okay. So these are the A, the FT, and the EW. They are all ratios, right? They are all ratio means they are less than 1, right? Then times 60, you come out with the available minutes per hour. The next one is the workload. So workload means how much work you have to carry. Well, how much work do I have to carry? It really depends on the flow rate. Means how frequent, right? How frequent we are transporting materials. It means how many deliveries per hour. Right? For one example of the unit will be delivery per hour. And also times the cycle time, right? And how often we deliver materials, cycle time. So this is how we calculate the total workload. And if you want to find out how many carriers do we need, then we just use the total workload divided by available time, right? Total workload, available time per vehicle or per carrier, right? Then we can find out how many carriers do we need, right? For example, we have a job that we need to move some bricks, from one place to another. Then we have 1,000 bricks, and we say, okay, for one person it can move maybe 10 bricks per hour. Then now we can calculate how many people do we need, right? So this is same type of calculation. Now let's use one example to demonstrate how we can use those equations in analysis. So this is a loop system with AGVs layout, and the vehicles travel counterclockwise, so which is this direction, counterclockwise, and around the loop to deliver loads from the load station. So this is a load station, and this is the unload station. Okay. So loading time at the load station is 0.75 minutes, while the unloading time at the unload station is 0.5 minutes. So the following performance parameters are given. The vehicle speed, we know the vehicle speed. Availability is there, 0.95. Traffic factor, 0.9. And also operator efficiency does not apply here in this case. So in this case, EW will be 1, right? All right. So from these three parameters, we can actually calculate how the availability of the vehicle, right? So basically, how many minutes available during 1 hour. All right. So the question asks us to determine the travel distances loaded and empty, right? The ideal delivery cycle time. We know how to calculate cycle time, right? And also the number of vehicles required to satisfy delivery demand if a total of 40 deliveries per hour must be completed by the AGVS. So we know the workload. All right, so first let's look at the travel distances. For the travel distances, basically there are two distances. The one is the loaded, the other one empty. So loaded, we can see the vehicle will be loading the material here and also unload here, right? Unload here, which means the vehicle is traveling this distance, right? This distance. So we just need to calculate how long it is. We know this is 20, this is 55, so this should be a 35. This is a 40, and this is another 35. You can find out is actually 110, right? 110 meters. Well, what about empty? Empty. So after this is unloaded, the material will have to be the equipment will have to move from here to here. So basically, we just need to calculate these distances. We know this is 20, this is 20, and this is 40, right? So the empty distance will be 80 meters. 80 meters, right? Well, if you want to calculate the deliver cycle time, right? Deliver cycle time. We know the cycle time equals to what? Equals to the loading time, right? The loading time. The loading time is 0.75, right? Loading plus unloading, right? Plus unloading. Unloading is 0.5. And plus what? Plus the transportation time from here to here, right? The red line, the red one. We know the distance is 110, right? And what about speed? So speed is 50 meters per minute, right? 50 meters per minute. And also we need to calculate the blue line's time, so which is 80, right? 80 divided by the speed. Then we can calculate what is cycle time. Well, in terms of the C, what is number of vehicles required, we know that we need to use what? Number of vehicles, we need to use total workload, right? Total workload divided by what? Divided by availability. So total workload will be what? Will be the frequency times the cycle time. What is frequency? Frequency is 40 deliveries per hour. 40 times the workload. Cycle time. So how do we know the cycle time? Man, we already calculate from here. This should be 5:05 minutes, right? 5:05 minutes, right? Times, times 5.05, right? This is the workload divided by availability. So availability equals to what? 60, remember, times what? Times the F, the availability factor, which is 0.95, times what? Times the traffic factor. Right? Traffic factor is 0.9, and then times the operator efficiency, which is 1 in this problem. So this is how we calculate the number of vehicles that are required. Actually equals to 3.94, which is close to 4, which is used 4. So this is how we calculate do some analysis about material transport systems. So mainly we just look at the cycle time, the total travel distance, and also how many vehicles do we need. And the solution is shown here. All right, so that's all for this lecture.